The valley Großes Walsertal is a steep, mountainous and sparsely populated region located in the far west of Austria. About 3,400 inhabitants live in this area of 200 square kilometers. Since the year 2000, the Großes Walsertal is part of the UNESCO Man and Biosphere program and therefore a model region for a sustainable way of life and economic activity. Using natural resources without harming nature, that's what people are doing here. Energy plays an important role in this system. The Austrian region of Vorarlberg is aiming for energy autonomy by the year 2050, and hence the Großes Walsertal is striving to reach a 100% self-sufficiency with regional and renewable energy. This means that the amount of energy produced from solar and hydropower must be increased. Currently, several small hydropower plants generate a total output power of 3 megawatts. The unused potential is another 10 megawatts, but can't presently be exploited. On the one hand, this is due to the fact that part of the water is of grade 1 quality and protected. On the other hand, the traditional electricity supply system would not be able to cope with such an amount of energy. In this tourist region, with its hotels and ski lifts, the consumption of electricity is relatively high in winter. At the same time, there is only little water to supply the hydropower plants. But when snow melts in springtime, power stations tend to reach their capacity limit and produce a lot more electricity than the inhabitants of the valley consume. The excess of energy must be transported through the whole 20-kilometer length of the valley. As a result, voltage starts to rise. To ensure the successful operation of electric devices, certain limits may not be exceeded. Resources are managed carefully. Using the technology of the smart grids, renewable energy may be fed into the electricity supply system in rural areas. The Biosphere Reserve of Großes Walsertal was selected to become the region to test the intelligent voltage control of Vorarlberg nets. True to the motto, "Bytes instead of diggers," in future, the existing infrastructure will be used to absorb the energy of numerous dispersed producers, like small hydropower plants, photovoltaic power systems, and biogas plants. Instead of spending a lot of money in laying cables, the energy system will be connected to new information and communication technologies, and therefore used in a better way. Traditionally, electricity supply systems are designed as one-way streets, while in the smart grids there is oncoming traffic. These are able to forward energies in both directions, from the producer to the consumer and the other way around. In the Biosphere Reserve of Großes Walsertal, the planning engineers of Vorarlberg Netz and their colleagues in the regions of Upper Austria and Salzburg, as well as industrial and scientific partners, have realized the first smart grid in Vorarlberg. To verify whether the technology can be used in other rural regions as well, another test system was set in the region of Salzburg. Its core is a central processor located in the System Control Center in Bregenz, called Central Voltage Control Unit, CVCU. At various critical nodes of the test system in the Großes Walsertal, 16 points of measurement were installed. These continuously provide the control center with the latest data. Particularly big consumers and power stations located at peripheral points of the network, where considerable deviation of voltage may occur, are defined as critical nodes. Via different communication mediums, such as middle voltage power line carrier, radio data transmission, optical fiber and copper conductors, voltage levels are continuously transmitted from the 16 points of measurement to the CVCU. The latter evaluates that information and communicates an optimized set value to the main transformer substation in Nenzing, the gateway to the Biosphere Reserve. Its regulating transformers are controlled in a way that ensures limits of operating voltage are never exceeded in any part of the system. This is now called an active distribution grid. We call this strategy of regulation remote control. Additionally, the synchronous generators of the small hydropower plants can be accessed in their reactive power management to support the system. In the process of this coordinated voltage control, the CVCU sends adjusting commands to the power plants. In this way, a maximum of existing grid reserves may be accessed. For further optimization, the CVCU can operate in several modes according to the specific requirements. Lower limit, prevalence of energy input. Upper limit, prevalence of energy output. Centered, power quality maximization, or minimal transformer tapping, to preserve the tap changer of the voltage transformer.
Die Analysen zeigen,
Analyses reveal that the cost for a conventional reinforcement of the supply system are considerably higher than those of the intelligent voltage control. With this technique, expensive reinforcing of the grid can be delayed, but not totally avoided. If the concept of coordinated voltage control stands the test in the Großes Walsertal, this technology will also be used in other regions where considerable alternative sources of energy are peripherally fed into the medium voltage power grid. Smart grids are not only a technical innovation, but also economically profitable.